Hi, if you're watching this video, it's because you missed Tuesday this week of school. So hopefully you're watching it sooner than later. So this was a pretty important lesson. There were a couple key points that you needed to understand in this. So we talked about nuclear fusion again. So make sure you know that nuclear fusion occurs in the core. And the core is also where the heaviest element that is fused will reside. So as a star gets bigger and bigger, the core gets denser and denser, and it's always made up of the heaviest atom in the star. So this star is showing that helium is in the core. That's because helium is more dense than the hydrogen on the outside. And we're going to talk about two different types of stars. So small mass stars, which are like the size of the sun or smaller, and then high mass stars, which are multiple times the size of our star. And what what the difference is between the two and what kind of elements they make. So really big stars have an iron core at the end of their life. If you look at this data table, it tells you that most of the star's life is spent fusing hydrogen to helium. And then the next most of its life is spent fusing helium to carbon. And then it goes really fast after that. So after it starts fusing carbon, its life expectancy shortens dramatically, and it only takes a short time for it to die after that. So carbon to oxygen, it does that for about 600 years, and then it goes to 6 months. And then once it starts fusing iron, it's about ready to die. So we're talking about days, hours until it dies. So astronomers will look through spectroscopes at stars and wait for the iron to start being produced, because then they know that's a place to look to watch a supernova. Um, so over here you can see the iron is in the center, and then each element after that is the next, so it's higher up on the periodic table. So for example, this is iron, it's number 26, where silicon's number 14, oxygen is 8, carbon is 6, helium is 2, and hydrogen is 1. So when I say higher, I meant like physically, it's above it. Okay. This is a small star. So there's a big difference in looks. So the one that looks like an onion and has layers like Shrek does, that one is always going to be a bigger star. And you should be able to key in on that if there's like a test question, and know that it's always going to be a big star, like multiple masses of our sun, if it has iron in its core. This one is what our sun's going to turn into. So it's a small star, and it only fuses up to carbon. So you can see carbon's in the center, and then it's just helium, and last on the outside it's still hydrogen. So it only has 3 layers. We looked at this graph and the data table. So make sure that you are able to identify, using this information, how long a star is going to live based upon its mass. So for example, if a star has a mass of 0.5, so it's half that of our star, of our sun, then it's going to live, you follow this up to here, it's going to live about 57 billion years. You could also find it out using the data table. So right here it says stellar mass. If you go down 0.5 solar masses, it's going to be 6, but there's a 10 here, so that actually means it's 60 billion years. So if it's to the 9th, that's a billion. Since this is to the 10th, it's really saying it's 60 billion years. So these both concur, they say the same thing. If we go in the other direction, the 2, so it's twice the size of our star, then you can see you go up, it's somewhere between 0 and 5, about 2. And then if we look here, Here's 2 solar masses, and it says 2 billion years. Okay, and of course we should already know our star is going to live about 10 billion years. So our star, this one says 9 billion years, which is close. When you're talking in huge numbers, billions aren't, if you're a billion off, it's not too bad. We made a T-table in our notes, so make sure you get this done. So when a star is in the longest part of its life, it can have 2 routes. It can be a small star or a big star. If it's a small star, it lives a really long time. If it's a big star, it lives only a short time. And if you need to go back, you can look at the slide just before this to see that. Small stars only do nuclear fusion to carbon. Big stars do nuclear fusion all the way to iron. This burns really slow. This burns really fast. So it burns faster because it's hotter, and it's hotter because it has more mass being squished together in its core. Okay, this one makes fewer elements. This one, of course, makes 26 elements. So a lot more. This makes 6 elements. This makes 26. So much more elements are created. So what we did in class is we made a poster, and on your poster you need to have these elements. So there's 3 main elements. You have to say how the elements are created, and they're created 3 ways: the Big Bang, stars, and supernova. Okay, and then you have to say what's the relationship between star mass and the elements somewhere in your poster or your diagram. And remember, there's 2 types of stars that we talk about. Small stars, which are the size of our sun or smaller, and big stars. So make sure you include that on your poster. And then how do we know? We know this because of spectroscopes. So you have to use the word spectroscope somehow or draw a diagram to include it. So here are some examples of your classmates. So you can see they show the Big Bang and they show the elements created. They show stars and they show the elements created in each kind of star: small star, big stars. And then they show the supernova event just from the big, and they show the elements created, so the heaviest, and then they are showing the spectroscope, and they also show the life expectancy. So you can see this poster has all the elements required. Here's another one. They did a pretty good job here too. So I like the life bars at the bottom. I thought that was cute. So we have small stars, big stars. They say what elements. They have a supernova, and they have the Big Bang. They didn't label hydrogen and helium, but they did a pretty good job. And then they did a good job on the 3 stages. So Big Bang, star, supernova. They show the elements made it in each. Anyway, I hope you get the idea. Here's another one. This one shows the spectroscope, Big Bang, stars. They left out the supernova. You can see we're not perfect. So probably the best one to go off of is this one. All right, I hope that's helpful. Make sure you get your poster turned in. It can just be on a regular sheet of paper. Obviously, it doesn't need to be a poster. So a good 8.5 by 11 would be perfect. Make sure your name's on it and turn it into the box. Thanks.